So, you good? So today I'm going to talk to you about how, if you're not doing IPv6 today, you're probably negatively impacting your users. And this is kind of like an oxymoron because you'd think it's a larger packet size, so it's got to be slower, right? Because you're sending more packets over the air or over the wire. The issue is this isn't necessarily the case. So if we look at the way the internet is built today, we're just a bunch of NATs. You either have a NAT in your home, there's a big carrier-grade NAT for your mobile devices, and there's more and more ISPs around the world that are looking at ways to deploy NATs to the home users, to whatever sort of users you want to impact, that you're going to just lose that end-to-end connectivity. And these NATs are just going to slow things down. I don't care what vendors say, they do slow things down. You know, the issue is, for years, why isn't this not coming up? Oh, I hit the wrong button. So, again, IP was originally envisioned for end-to-end communication. We've lost that with the proliferation of IPv4 and the growth of the internet. And because of such a short address space, we don't have the ability to do end-to-end communication. IPv6 is going to allow us to get there. So the question is, you're going to ask, how do we actually know that v6 is faster? Well, a little over 3 years ago, we, along with a bunch of other industry-leading companies, decided that we would turn on v6. And this was a pretty huge risk because nobody had ever done v6 at scale on the internet. It had always been this thing that people did in their homes, through tunnels, and whatnot. So we've been gathering data for the last 3 years on what the performance characteristics are and anything we can possibly get to see, is it better, is it worse, how's it impacting people? So, we have this great tool set at Facebook called Scuba, and we just put all sorts of data in there. And I started looking at how long total requests were taking on v6 versus v4. And this is one of those tables. And the top line is v6, and the bottom line is v4. And you're wondering, it can't be 40% faster. Even I said it can't be 40% faster. There's no way this is absolutely possible. So then I got to thinking, maybe we need to do some more testing. So what ended up happening is we went through and we instrumented our clients. And we basically built the clients so that we could A/B test users against v4 and v6. And what we ended up doing is we ended up focusing more on mobile providers than fixed line, since we could control the experience. And what we found is that when I actually went and got some data scientists to actually sit down and figure out what was going on, they came back and they said, guess what? It is faster. It's only 15% faster. But 15% faster is still significant. These are huge performance wins. And as we all know, when you make things faster, it drives other key business metrics in the positive direction. So, we ended up taking this data and we looked at every carrier in the United States that was doing v6. And the data shows the same thing across carriers, and it's pretty impactful. So then you're going to ask, why did Facebook and all these other companies take the risk? Well, this is a graph showing how many IPv4 addresses are still available at the various regional registries. And as you can see, it's been a straight line down for years, and more so in the past few years. If you look, Aaron, APNIC, RIPE, they're all out. They're effectively out. There is no more v4 to be gotten. You either have to go out, pay lots of money to get it, or your cloud providers are hoarding them. It's going to get messy. So then you've got to wonder, okay, how much v6 is actually out there, right? There can't possibly be that much. Well, when we got together in 2012 to launch this on World v6 launch day, there was only 1%, and that was a huge feat to get 1% of the world on v6. My colleagues here today that were involved with that, they knew that it was really difficult, and we didn't know if we'd actually hit it. But now if you looked, today we're over 10%, and we've been doubling roughly year over year with an acceleration over the last few years. But the more interesting metrics are what happens in the United States, for me at least. 23% of the people in the United States come to Facebook every day over IPv6. So if you just look around you, someone here is using v6. But what's even more interesting is on mobile, right? 33% of mobile users in the United States use IPv6. So that's 33% of the people, 1 in 3. But what's even bigger is the high-end users, the people that consume the most amount of data, the people that have the high-end phones, the high-end connections. When you look at 4G networks, it's 45%. Okay? Just think about that. By the end of this year, it's going to be over 50%. Okay? So the question is what happens if you don't adopt? Okay? V4 is out today. You're going to end up spending money. Do you want to spend money on IP addresses, or do you want to spend money on engineers? I know what I want to spend money on. You know, then you got to think about the developing world. Okay, there's all sorts of people in the world that don't have IP connectivity today, and there's all sorts of new ISPs cropping up every day. What happens when they can't get V4 address? They can't even get NATed V4 addresses. Okay, if I'm an upstart business, I can go turn on V6, and I get a good percentage of the internet today, but I don't get all of it, because what's happening is there's a content problem. Okay, we have the big players doing V6 today, but we don't have everybody else. So you end up with this content problem while we have this growing eyeball, sense of V6 users. So if it's already so great, why haven't we done this already? Well, as many of you know, in the 1990s, late 90s, we had the dot-com crash. Well, IPv6 was ratified in 98. And people were ready to go to it, but the problem was that we didn't have the money, and people didn't want to migrate after the crash happened. Then we created things like GNATs, and that mitigated the need and the growth of V4. So we've had this slowdown. And then now we've built up 20 years of V4 knowledge. And people are afraid. They're afraid of the change. They think, oh my God, it's a different IP address. It's going to be different. My firewalls are going to, my NAT, there's no NAT in V6. I'm insecure because my NAT is my firewall, right? No. Firewalls exist for V6. But the biggest issue is the boy who cried wolf, right? For 20 years, if you've got somebody going out there, we need V6, and then they come up to you and you're like, no, we don't. And that's been the case for the last 20 years. But today, there is a real need. We can either build an internet full of NATs and full of boxes in the middle that get from our users to their devices, or we can have an unfettered end-to-end communication and return to what the original intent of IP was. So then you're going, okay, I actually want to do this. What do I need to do? Well, a lot of people think they've got to convert everything. They've got to migrate their entire infrastructure. They've got to spend countless hours of engineering making this all work. But the first thing you've got to do is you've got to turn it on in your offices. Okay? That's just like the simplest thing to do. If you look, the home is killing the corporate environment in terms of V6 penetration. Okay? There is very little corporate V6, and that's a huge problem because you can't adequately test this and make sure it works without your V6 working inside your offices. Then you're going to go, okay, well, I get it in my offices, but my cloud provider doesn't have it, or my data center doesn't do it, or whoever, right? Well, guess what? There's plenty of CDN providers that will end up doing it for you. Funny story, right? The at-scale conference website didn't have V6, and I've given enough of these talks over the past few years where I don't give a talk anymore if it's not dual stacked. And so I went to the company that was building the site for us, and I said, hey, you need to turn it on. And it happened to be hosted in Amazon EC2. And we're like, oh, look, the ELB supports it. We'll just use the ELB host name that's dual stack. And we go and we turn that on, and it doesn't work. And I'm like, what the hell? So I go and I say, oh, we're using an EC2 VPC instance. And I'm like, crap, it doesn't work on those. Let's go to Classic. Nope, can't go to Classic. So we're like, crap. So what did we do? We went to Cloudflare. It actually worked. It took us about 15 minutes. If you don't believe me, here are my dogs. They have a website, very nicely designed, but it doesn't have IPv6. And we were pretty sad. So I'm going to go through these really quickly just to show you how fast it was for us to do it. We plugged it in, and then Cloudflare wastes a minute of your life showing you this video. And I just put these. I I was told I had too many slides, but I was like, I wanted to prove a point that they could have just shown you this slide, which says, go update your glue records. So we go over to where we hosted the domain. We change it. We hit submit. We come back to Cloudflare. Everything says, yay. They've got this little button. You click turn on IPv6. It's on. My dogs are happy. So again, might be oversimplifying it, but it's not that hard. And the issue is if you want to get it to your end users. The recap of all of this is, don't be late because content needs to get there. You're leaving performance on the table. There's, if you look at the way the mobile world is built, it's built through large carrier-grade NATs or direct v6 connectivity. And the performance gains are real. The other impacts of that increased performance are very, very real for Facebook and for everyone else. And what I'd like to do now is bring up some major carriers in the world who have agreed to join us today. They want to talk to us about why v6 is important to them and how it should be important to you. So I'd like to introduce John from Comcast, Samir from Verizon Wireless, Yoon from SK Telecom, and Axel from Deutsche Telekom. Oh, here we go. There we go.
Can you hear me now?
Yeah, I know. So we wanted to bring these guys up here because we felt like it was necessary to let you know that the carriers and everybody are interested in making sure that more content is available. And so I have a bunch of questions, and we're just going to go through them. And the first question that I have is directed at all four of them, and they'll all answer very quickly, I hope. What surprising things did you guys discover on your move to IPv6? John, I guess you can start.
One of the things that it was funny because in the early days of our deployment, Paul, which dated back about 10 years now, it was a hard sell, right? We tried not to be the boy who cried wolf, but we found that over the years we had these little breadcrumbs of things that were actually operationally 1,000 times more, 1,000 times easier than before. And that all kind of culminated over the years in how we manage the network, operate the network, only to find that recently, and for those of you who watch news about Comcast, you'll kind of get the joke here. We also found that with v6, if you ever intend to merge two large networks together, it's actually pretty helpful. So there were so many kind of little things over the past 10 years that actually were in some significant operational benefits, not having to juggle v4 addresses and such.
Thanks, John. So from the Verizon wireless perspective, when we started doing v6, it really coincided with the launch of LTE in 2010. And we didn't really start picking up till, let's say, 2011-12 when we started releasing smartphones that were running on the LTE network. And in the beginning, I wasn't really sure how much traffic we're going to see. But just similar to what Paul showed, we've grown from doing a couple of percentage worth of traffic all the way. Right now, we have about 50% of all the traffic out of Verizon is over v6. And you look at some of the bigger providers, like I think with Facebook, we're doing about 80%, similar numbers with Google. So the interesting thing for me was that you're turning this technology on the carrier side. As soon as content becomes available, especially from the big players on the internet, you start moving the needle very quickly.
Just take the other one. They're connected with IPv4.
Right. Yeah, it's accelerating, but it's still slow. I think the main reason is that because of the motivation and cost. At least from the perspective of users, they don't feel any inconvenience with current situation. And in the cost perspective, V4 operation cost doesn't much higher than transition to V6. So that is to say, motivation and initial costs are harder to transition. But as a mobile operator serving most mobile internet users, we thought that we must be at the front line of this transition. So top management made the decision and justified spending money and time for this project. And once we took first step, that was easy. Everybody from each department, from development, deployment, test, and operation, all people were very cooperative, and nobody had a doubt about the essence of the project. So I think this is the very positive, surprising thing I discovered during the move. Once you get started, it will go.
Yeah. Okay, so I'm the only one with 2 mics. I have to admit, it didn't really surprise me that V6 gave us simplicity. I guess I should put it there. Working with IPv6 since the days before it was actually called IPv6, simplicity and scale are, I think, the 2 main points for us. Anyone managing private addressing plans for data centers, for internal services, gone. You only do it once, you do it based on V6. You can build some simple security schemes based on V6 addresses. And the only thing I'm missing so far is indeed the comeback of the end-to-end, because we still have too much NAT around. But once you move towards a true IPv6 only core, NAT's gone, your headache's gone.
Thank you. Samir, so you've heard me talk about the performance characteristics that we've observed. Is there anything that you guys have been able to tell from your large deployment?
Yeah, so we've been looking at performance as well. A lot of cases, the guys on the network side really look at saturated performance, but once Paul started sharing some numbers with me, we went and double-checked, and I was actually surprised to see and effectively validate his claims that we were seeing better performance on V6. I think a lot of that has to do with the NATs on V4, and just getting traffic through the NATs is problematic. So I completely agree. I mean, the performance of V6 right now anyway is definitely showing much more improvement over V4.
So why does IPv6 matter to the fixed line and wireless operators?
So Paul, from our point of view, it just we couldn't grow. We saw no growth in the future without it. 10 years ago, we were doing the dance, as Axel was kind of alluding to, with trying to figure out how we were going to get enough IPv4 addresses to do the things we need to do, and V6 was really the only answer, right? If I had a slide, there's one slide I would show you. We can show the number of kind of devices on the network today, and there is about a third of them that are new devices that have never seen IPv4, and that third new is higher than our peak ever at V4. So it's really kind of lifted the ceiling away from kind of anything that could have hampered growth, at least from that point of view.
What was the question?
Why did deploying IPv6 matter to
so
you?
Everyone's talking about Internet of Things these days. I think that was one of the big, I think when we started, we were calling it M2M. But that was a big motivator for us. Frankly, I don't see why you should have any IoT devices that are doing V4 at all, unless there's a specific need to do them. And doing V6 makes perfect sense, especially if you want to have performance and direct access to the endpoints.
Okay, we are out of IPv4 address. That means we had to allocate private IP and use NAT for external communication. NAT itself is inherently introduced complex and delay. And it may look very negligible for now, but when we move toward 5G, we are thinking of many mission critical use cases that is very delay sensitive. We are thinking of under 1 millisecond end-to-end delay for certain use cases. So this can be achieved by various technology together, but fundamentally, network should be simple as much as possible. So this should not be there.
Yeah, so for us, it's two sides. Actually, as mentioned, IPv6 means simplicity, and simplicity translates into lower OPEX, so that is sure an important point. The other one is actually on the customer side. If you look at things, IoT was already mentioned, home automation. In the future, we're going to have routed networks at home. You can't run them without IPv6. You can't run these applications, and maybe it's a little bit tighter security you would need for your home if you're moving towards home automation for all your devices at home, also for your critical infrastructure at home. You can't do it without V6, so you have to go down that route.
So my final question has to do about what do you need from people here in the audience to do? Because we've talked about like what Facebook has done and what you guys have done, but the big issue is what does everybody else in the world need to do?
So Paul, I think this falls into two buckets for us. I think one, folks, maybe both of them folks here can kind of do something about. As you alluded to during your talk, content is slowed down a little bit. We really need to see a push in this space for additional content. But one of the things that we've also observed is from a consumer electronics point of view. So I think to put the ask succinctly, if anybody here builds applications that run on, a wide range of consumer electronic devices, not just phones or tablets, but anything else. If it doesn't support V6, make it support V6, and if it's not hosted on something that supports V6, go find someplace else to host it. I think that's how I would summarize it.
Yeah, I think, I'm actually surprised to see this many people on the V6 talk. So it's encouraging that I'm assuming you guys are here because you guys are going to go back to your respective jobs and turn on V6. So we do want to see a lot more content moving to V6. My other request is, where possible, try not to fall back to V4. We're still working through a few kinks, and when people fall back to V4, although that may be the right from a consumer perspective, you mask a lot of issues. So try to stick on V6, stick with your guns.
Even after our mobile network support V6, and new device comes with V6 only functionality, we still need IP conversion for external communication with the non-V6 apps and applications. This limits the advantage of migration. So I know that it will take time for the whole ecosystem to be V6, and V4 will function for the years to come. But for the benefit of our ecosystem, we all need to act now together. And innovations will scale to its full potential only within IPv6 enabled networks.
Yeah, V6 has to become the norm, and V4 has to be the exception. So I need all of you to actually remember that. And sure, we have some work areas, like Paul mentioned, connectivity into the offices. When I checked upstairs, I believe the show network is not supporting V6 either.
I'll work on that next year.
But we're getting there.
So I actually have time for one more. This is geared to the mobile operators. So with Apple's announcement of iOS 9 requiring the work that applications work on V6 only networks, what does that mean for you guys and going forward?
Well, I think immediately starting, I guess, on the 16th, I'm expecting to see a lot more V6 traffic show up. My guess is, we're doing 50% right now. I'm hoping in about a year's time, we're closer to 70.
As I mentioned, network is ready. All we need is new device and webs and applications.
Yeah, it doesn't come as a surprise. So we had a couple of years actually prep time for that. And it's not only Apple, it's also with some of the other devices on the market which require that. So just business as usual, I would say.
Yeah, I think what most people may not realize is that sometime next year, Apple has threatened to stop updating apps if they don't work on v6 only connections, which will basically force engineers to rewrite their applications to work in these environments so that mobile operators can potentially deploy v6 only networks.
Can I do that too?
You can do whatever you want.
I appreciate that. It means a lot to us as well. I mean, we have 25% of our traffic or so is v6 today, and we think movement like we're seeing from Apple will help us really get to seeing significant increase in that space. I mean, I think by the early part of next year, we'd very much like to be in a spot like the rest of the guys are here, or at least Samir anyway, where we're over 50% of our traffic is v6.
So anyway, that's all we have. Come by office hours if you have any questions. Thank you, and please turn on v6 because we're enjoying the benefits, and so should you.